Hi, everybody. What we're going to be talking about today is the ambiguous case for law of signs. Now, you've already done a bit of work with law of signs, but what we did, we actually held back on a little information for you to be able to get comfortable with law of signs. So, what we have to tell you now is that with the given information, certain scenarios can result in what we call the ambiguous case. Okay, so here's what we have to do. When we're working with law of signs, we have to determine from the information that is given whether or not a triangle could even exist. Because there are times with the given information you couldn't even make a triangle out of those sides and angles. It's possible that we could make exactly one triangle, or what the ambiguous case is when the information would actually allow us to make two different triangles based on the information that's given to us. So that's what we're going to talk about today, how to identify when we have one scenario over another, and then what to do with it. So if you look at what I have drawn here, I just drew a right triangle and I wrote out SOHCAHTOA using, SOHCAHTOA, sine over cosine, sine equals opposite over hypotenuse, cosine and tangent, you know those. And I'm calling this the right angle. So we get that the sine of A equals A over the hypotenuse, which is B. And just doing a little rewrite, we get B times the sine of A equals the length of A. Now, here's the important part. B sine A actually represents the shortest distance from this point here to this side here. So, if we're going to talk about how B side A plays into whether we can have one, two, or three triangles. So, let's get into it. The first scenario that we have shows that A, the side length A, is less than B. So we're going to be giving you information. We're going to be giving you an angle, a side, and another side. So that's why we're saying this right here. This is the information we'll be giving you. In this particular case, notice that for all of these, the angle that we're given is acute. And for the first three scenarios, side A is less than or shorter than side B. Okay, so the side across from the angle that's given, A, is less than the other side that is given. Okay, so if in this case A is less than B sine A, what that would mean if we were to kind of draw this is that this segment right here up in our triangle, I'm trying to do it in red so you can see it, wouldn't even be long enough to meet here at a right angle. So we would have 0 triangles, which means we would have no solutions. It wouldn't be possible to do law of sines or cosines or anything because we wouldn't even have a triangle. Okay. The second scenario is, again, you have to have angle A is acute and the side A compared to B sine A. If the side A is equal to B sine A, well, that's this scenario right here that I drew first. We would have exactly one solution because what that means is that this side right here, again, I'll draw it in red, actually meets at a right angle with this side, the third side. So there's one other scenario, and that scenario is if side A is longer than or bigger than, I shouldn't say longer than, bigger than B sine A. This is the case where we will get two solutions. And the reason we'll get two solutions is that longer side could be in here, making a triangle like this, okay? Or the longer side could have tilted out, making a triangle. I'll go with a different color. Going out this way, which would have made this triangle. Okay, so we would actually get two possible solutions in that case. And in that case, we would have to solve for both solutions, showing the triangle could be this size or it could be, having these measurements. Okay? Given the same initial information, which is that angle A is acute, if side A is bigger than B, we will have exactly one solution. Nothing to think about there. Just exactly one solution. And then you would go and solve using law of sines like we did, before you got this lesson. Okay. Okay. So now what we're going to do is we're going to talk about the second case. And the second case is, remember, these were all if angle A was acute. So now we're going to talk about if angle A is either equal to 90 degrees or obtuse. So in either one of those cases, if A, the side opposite the given angle, is less than or equal to B, we will have no solutions. Again, you would not be able to make that triangle. And if the side A was bigger than B, and again, it's the side opposite the 90-degree angle, you would have exactly one solution. And then you move on from there. Now listen, there are no two ways about this. You have to memorize this chart. You have to be able to, figure out right from the get-go, okay, I'm going to compare, I have, an acute angle, so I'm going to use one of these methods or these tests. Okay, I have an obtuse angle or a right angle. Well, then I just have to use, I just have to, I don't know, I have to use one of these methods. Okay, so let's go ahead to the next page. Let's take a look at what we have. Okay, and take a moment and see on example 1A, what you'll see is that you have an acute angle that's been given you, and that the angle the side opposite that angle is less than the other side. So here's how I start to write these out. I would say, first of all, I write acute over here. I want to make sure I'm using the right test. And then I say A is less than B. Because what that does is that pushes me in the right direction to compare A to B sine A. So I would write A, B sine A. Okay, A is 8, B is 10, and A is 30. Now, you can actually do this out without a calculator because you know that the sine of 30 is 1/2. Remember our unit circle? Never going away. And half of 10 is 5. So what we find out is 8 is bigger than 5. If you look back to the previous page, what you'll see is that would actually be a triangle with two solutions. Okay, it's in the first chart. A was less than B, so if you think about how that first chart looked, the first three things, there were three scenarios. All three were A was less than B. Okay, and in the last one, A was bigger than B. Okay, so for example B, let's look at that one. Okay, example B, first thing off the bat, we have an obtuse angle. So you are not going to use the top chart, you're going to use the second one. And we only have to compare B to C. So the side that's opposite the given angle and the other side. Well, we can clearly see that 8 is less than 10. If you look back, I'll scroll back here. Okay. If the given side that's opposite the given angle is less than or equal to the other side, you will have no solution. You couldn't even make a triangle. So that's what we have here. No solution. You can write it like that, or you can write it like this. So what I'd like for you to do is I'd like for you to pause. Geez, I'm having issues here. I'd like for you to pause the video and then go ahead and see if you can determine how many triangles we would have with this given information. Okay, so go ahead and pause that video. Okay, couple things. I want to make sure you're on the right track. This angle that's given here is acute. Okay, and obviously this is the side across from that. In letter B, this angle right here is obtuse, and these two are across from each other. So, seeing that we have an acute angle, we're going to compare A to B sine A. And in the other case, because we have an obtuse angle, we're simply going to compare the length of A to the length of B. Okay, so hopefully you paused the video as I asked, did these calculations, and after doing the calculations, it should be pretty obvious that 18 is less than 22.3, which means, okay, A is less than B sine A, so there's no solution. In other words, remember we talked about that altitude that wouldn't even reach. It would look something like this. Okay, it wouldn't even reach toward the shortest distance. In the other scenario where we have an obtuse angle, the side across from the obtuse angle is bigger than the other given side, which means we will have exactly one solution. Okay? So we're going to go ahead and we're going to do example 2. And in example 2, we're told to find all of the solutions for each triangle. And if no solution exists, we have to write none. So first thing we have to do is we have to decide how many solutions do we have. So when I look at this, I see we have an obtuse angle that's been given to us. Okay, so I know I'm using that second chart. And this is the side that was opposite 112 degrees. So I have to compare 4 to 3. Well, that's an easy comparison. 4 is bigger than 3. So we have exactly one solution. And we're going to start to draw our triangle. I think it's important to draw it just to kind of get an idea of what it's going to look like. So we know we have a 112 degree angle. So we'll try to put the obtuse angle in there. So angle A is 112 degrees. Side A was 4 units long. And then we'll just say angles B and C. If this is angle B, this means this is side B, which is 3 units long. Now remember, we can use law of sines for this because we actually have a side and an angle that are opposite each other. So we have the sine of 112 is to 4 as the sine of B is to 3. And what this will do is this will help us calculate the measure of angle B. So of course we can cross multiply and then divide by 4. So we'll get the sine of B equals 3 times the sine of 112 divided by 4. And of course, if we're going to be calculating the sine, we have to take the inverse sine of each side. Okay. So this should all go in your calculator in one shot. B equals the inverse sine of, and then put that fraction in there. And make sure you do it on your calculator. Make sure you do it out. The measure of angle B should come out to be 44 degrees. If you don't get that, check and make sure that you're in degrees, not radians. And then also maybe you have to do it one piece at a time. Maybe you have to do sine of 112, get an answer, times 3 divided by 4, get an answer, inverse sine of your previous answer. Okay, that's kind of up to you. But what we know now is that this angle is 44 degrees, which means real simple to find the measure of angle C. It's simply 180 minus the given 112 minus the 44 that we just found, because remember the three angles of a triangle always add up to 180, and that gives us that the measure of angle C is 24 degrees. Now we have to use that 24 because that's going to help us calculate side C, which is over here. Now, if it were me, I would go right back to the 112 and the 4. Okay, so I would go right back to the sine of 112 is to 4 as the sine of angle C, which is 24 degrees, is to side C. And cross and divide. You'll get 4 times the sine of 24 divided by the sine of 112. Okay, and when you calculate C, again, make sure you check it. C is approximately 1.8. Okay, so this is about 1.8 over here. A quick check that we've talked about is, do our numbers even make sense? Here's the biggest angle, it's opposite 4. Here's the smallest angle, 24 degrees, it's opposite 1.8, which is the shortest side, and medium to medium. So at least it does make sense. Hopefully that'll help you, pick up on any silly mistakes that you might have made. Okay, so let's take a look at one more example. And in this last example, we have an acute angle. It's 51 degrees. Okay, so I'm going to write acute here. And I can see that A, the side across from the angle A is less than B, which means I have to do the comparison of A to B sine A. So 40 has to be compared with 50 times the sine of 51. Go ahead and do that in your calculators. What you should get is that 40 obviously doesn't change, but on the right side you get 38.9. So 40 is bigger than 38.9. And what that tells us is that it's possible for us to have two solutions. And you know what? We're so lucky. We get to calculate out the two solutions. So here's what we've been given. I'm going to kind of draw it here. It's not going to be drawn to scale because we're actually making two different triangles. But let's just take a look. So what we know is that angle A is 51 degrees. Side A is 40 degrees. And then side C is 50 degrees. Okay, so we're going to look at the two cases. So this is a big deal. Okay, this is all the information that we know for sure. Case number 1, I'm going to call the acute case. Okay, because what we're going to do is we're going to solve for angle C given the information that we have. So we'll simply say, so this is angle C right up here. We'll simply use law of sines. So sine of 51 is to 40 as sine of C is to 50. That's old news. You're going to cross and solve. So you wind up with sine of angle C equals 50 times the sine of 51, all divided by 40. It's getting a little crunched over here for me, but we will take the inverse sine of each side, and you're going to put that in your calculators. And when you put this into the calculator, and here's why we know that we're going to do the acute version, is that we can actually get two solutions for this particular problem. The calculator will default to the answer that lands in quadrant 1. In other words, the answer that is acute. And we'll talk about principal values later. But when you put this into your calculator, you should get that the measure of angle C equals 76 degrees. So that's case number 1, where this would be a 76 degree angle. But that is right there going to tell us what we need to know about case number 2. So case number 1 was the acute value. Case number 2 is the obtuse value. And the obtuse value is simply the same angle, reference angle, think about that, if it would have landed in quadrant 2. And a very simple way to do this is to say 180 minus 76. And that is a 104-degree angle, which is the other possible measurement for angle C. So we'll hold off on that in a for a second, but getting this angle here actually gives us the angle in the other triangle, scenario 2, case 2. So listen, now that we know two angles in this triangle, we can go ahead and calculate the measure of angle B. Okay, so the measure of angle B will simply be 180 minus 76 minus 51, which is a 53-degree angle. Okay, so now we know that's a 53-degree angle. And we have all the measurements necessary to go ahead and calculate the last side, which is the length of side B. So I would go back to the original information. Sine of 51 is 240, right? As the sine of 53 is to B. And you'll do some calculations here. B equals, you're going to multiply 40 times the sine of 53. Doesn't look like a 3. And then divide that by the sine of 51. Again, do this in your calculator. I know I'm giving you the answer right now. The answer comes out to be about 41.4. I'm sorry, 41.1. Things aren't writing very well. So that's about 41.1. And at this point now, we've calculated all sides and all angles of our triangle. So we're done with that triangle. But we actually have to go to case 2 to now show, hey, this is the other way this problem could have landed because this is the other triangle we could have drawn. So if you recall, we have a 51-degree angle, but we also now have a 104-degree angle. So looking at this, okay, I'll keep my original 51 here. But now we're dealing with a 104-degree angle. So we have an obtuse triangle here. And you can see it takes on a different shape, obviously. We were given that side C is 50. This was angle A. And of course, we were told that side A was 40. So this is a quicker solve at this point because we already have two angles. So to get the measure, to get the measure of angle B, we're just going to, again, use the 180 rule, the triangle angle sum theorem, and we'll subtract 104. I don't know why this is not writing correctly. And subtract 51, and that's a very simple calculation. You get that the measure of angle B is 25 degrees. Okay, so we can kind of grab a different color here so it shows up. We've now calculated that angle, which means we can calculate the side opposite it using, you know it, law of sines. So the sine of 51, we're doing almost the same thing we did here. Okay, sine of 51 is to 40, as now we have the sine of 25 is to B. Okay, as usual, cross and solve. So B equals 40 times the sine of 25 divided by the sine of 51. You would just drop that into your calculators and you should get 21.8. Again, if you're not practicing in this in your calculators, you don't really know if you have your settings correct. You don't know if you actually know how to do it. So please make sure you're doing that. So that was a lot to take in. I want you to think about that. I want you to memorize that chart. Super important. Otherwise, you're not going to know when to test for one or two triangles, or when you don't have a triangle and you just say no solution. Okay? So have a wonderful day, everybody.